All right. Hey, welcome Algebra 2. I'm glad y'all are here. Sorry that I won't be here Friday, but live stream's going on now. So hopefully that you're here. Please comment below on whether or not you're here. So I'm just kind of checking, making sure
Going on now.
I'm
So
seeing
hopefully
that
that you're
it's there and streaming. So I see that it's working. So we're going to keep going. Just letting you know, this is the teacher lounge of the math building. As you can see, everyone's gone home, and so after this, I'll head home as well. So again, if you're here, please let me know. Comment. Right now, you might see this is under Brandon Johnson, but Brandon Johnson and Coach Jay. I had a little technical difficulties with mine, so I worked with Coach Jay, and we got it going. So without further ado, let's go into our review session today. So for today's review session, what we're going to do is essentially just look at the review guide. And as we're looking at the review guide, I need to share the screen. So let's see. Okay, there we go. Screen share. I want this. There we go. All right, a little screen inception. And I'm going to give it a second. I'm going to watch the live video. I have a live video stream for me to make sure I'm doing the right thing. And then after that, we'll get going. All right, perfect. We're going. So I've already had one question submitted by Jay Crawford. Shout out to Jay. Thank you for asking a question. He wants to review just the concept of the I variable and square roots. So I got problems. I got 3 problems for us to look at. For just square roots and the I variable. Just a little quick recap. What I represents is I is essentially equal to the square root of -1. So I is equivalent to the square root of -1. And if you ever see an I squared, that's going to be essentially the value of -1. The reason this is true is because if you look at the square root of -1 times the square root of -1, that's essentially multiplying the square root of -1 by itself. The square roots essentially go away to give us that -1 value. So that's just where I came from, is by square rooting the value of -1. So let's take a look at this square root of 40. So basically, what does this mean, this -1? If I have a negative underneath the radical, it's very helpful just to get that radical out, get rid of the negative, just say, hey, we know it's going to be I square root of 40. Now we have to reduce the radical. You have to reduce in order to get full credit. Now, what does it mean to reduce a radical? It means to see if there are any perfect squares that can go into radical. So if I'm looking at 40, do any perfect squares go into 40? One way I can view that is essentially by making a factor tree. And so if I'm making a factor tree, I know that the factor tree 40 is 4 times 10. And does 10 divide out? It does. 10 is 5 and 2. And then 4 is 2 and 2. Essentially what the factor tree does is, to see what factors is, I'm always going to be looking for a group of 2. I know 4 is a perfect square, so when I factor that out, that's going to leave me with a 2i. So I'm taking that group of 2 out, but this 5 and 2 is left behind. So that would mean that the 5 times the 2, whatever is left behind, stays underneath. So this simply reduces to 2i square root of 10. We're going to go till about 8 o'clock today, just a good solid hour. So I'm going to see how much we can do with this. So it's just, I don't know, it just depends on time. So again, if you have questions and you're just tuning in now, or at any point, please ask away, say hi or anything like that. So we're going to look again. Now notice that if I have a negative underneath the radical, the first thing that it's going to be helpful to do, just get rid of that negative by taking out the I. So now we have negative I square root of 88. Now let's look and see what values can go into 88. Well, I know 88 is 11 times 8. And if I break out 8, that's 4 and 2. Well, 4 is a perfect square. That's my group of 2. So what I'm going to do is pull out the 2 to get negative 2i. Essentially, I'm taking that group of 2, pulling out, and then what's left behind? This 2 and that 11 is left behind. So whatever is left behind is going to be staying underneath the radical to be multiplied. And then whatever is a group of 2 that I can pull out will be essentially pulled out of the radical. So then that would give me negative 2I root 2. So again, I'm just kind of doing as much as I can. So again, I see a couple people watching now. So if you are watching, please just send a comment, type it in just so that I know who's here, and then ask any questions as we're going along. So the last little radical thing that I'm going to look at is this, again, the square root of negative 36. This one's going to be a good one for us. Whenever, again, you have a radical with a negative underneath, the best thing to do is get rid of that negative and just say, hey, I'm looking at the square root of 36. Well, the square root of 36 is actually perfect square because it's going to be 6 times 6. That's my group of 2. I'm pulling that out to get negative 6I. And again, if this video, you still have questions after this, feel free to ask during class on Thursday. So that's essentially simplifying radicals in imaginary numbers. So what I want to look at next is adding imaginary numbers, subtracting imaginary numbers, and multiplying. Now, whenever we're looking at imaginary numbers, I always want it in the standard form of A plus BI. This is your imaginary number, and the A is represented by your real number. And so with A plus BI format, we want to essentially get the last term to be imaginary and the first term to be real. Now, when you first see this 2 parentheses, you're going to go, FOIL, I need to FOIL that. But look what's in the middle. Is this a plus sign or a multiplication sign? It's a plus sign. So all that means is we're going to add these together. So there's going to be 1 plus 5I plus 1 minus 3I. You can think of it that this plus 1 is being distributed to each term. So 1 times 1 is a positive 1. 1 times negative 3 is a negative 3I. And then you just combine like terms. So when we combine our like terms, we'll get 1 plus 1 to get 2. And then we combine 5I and negative 3I to get plus 2I. And this is the form that we want. This 2 plus 2I is that form, that A plus BI format. So we like that very much. Next one, it's again, rather than adding, we're subtracting. And because we're subtracting, I want to distribute the 1 to both of these terms. Now, nothing's happening to this 3 plus 2I. But to this negatives, we're going to distribute a negative 1 to a negative 3. When you distribute a value, you're multiplying negative 1 times negative 3. So that's going to give us a positive 3. And then distributing the negative 1 to that positive 4I, that's going to be a negative 4I. When you combine like terms, you combine your real numbers to get an 8. And then you combine your imaginary numbers to get a 6 minus 2I. So real with real, imaginary with imaginary. So essentially what that means is wherever you see a real number here, you're combining those values. And then wherever you see an imaginary number, you're combining those values. Now we've looked at addition and subtraction. What I want to look at next is some multiplication. And so because we're looking at multiplication, this is going to bring in our idea of FOIL. Now, remember, FOIL stands for first, outer, trying to get some color coordination going in, FOIL, inner, and last. Sorry, I want to get some color coordination. I won't do this for all the problems, but just so that you can see what values go with what. So the first means you're doing the first term times the first term. So you're doing 5 times 2 to get 10. From there, you're doing the first term times the last term to get plus 15i. And then you're going to do the inner term, meaning the negative 2i times the 2 to get negative 4i. And then you're going to do the last term, this negative 2i times 3i, to get a negative 6i. From there, we're just going to combine all of our terms together. And so when we combine them, we'll get the reals with the reals. Oh, wait, sorry. Moved a little too fast. If I have 2i times 3i, that's 2 times 3 to get 6. I times an I will give us an I squared. Now, here's a neat thing about I squared. I squared, if we recall going back to the first problem, is actually the value of -1. So because it's actually the value of -1, what we're going to do is change this -6i squared is actually going to turn into a -6 times a -1, which is equal to a +6. So this is not a -6i, it's actually going to be a +6. So now when we add the real numbers, we're going to get a 16 plus 11i. And so when you're foiling, just keep in mind, pay attention to those i's and I squares. Make sure that you know that an I times another I will be an I squared. And I squared is equal to -1. So let's just look at another FOIL opportunity. So looking at another FOIL, I'm not going to go into all the color details. We're just going to do FOIL in its entirety. So 5 times 5 will give us 25. And then 5 times 13i will give us a positive 65i. And negative 13i times 5 will give us a negative 65i. Then we'll have a negative 13 times a positive 13. Both of those have an i's. And so when we multiply those, we'll get a negative 169i squared. But again, this I squared is not going to be a positive 169i squared. It's actually make it a negative because we're doing a negative 169 times a -1 because that I squared's equal to -1. So you're essentially just multiplying that value there. From there, you're going to combine your like terms. Well, here's the neat thing. This 65i and negative 65i just cancel. So we're really just looking at 125 plus 169, which is 194. That pretty much concludes imaginary numbers. Again, if you have more help, please see me Thursday morning or Wednesday morning or anytime. Or just ask questions on the live chat. So now we're looking at problem number 8 here. So I have x squared minus 64. For problem 8 to 13, we're trying to solve by factoring. Here's the neat thing that we can do. If you ever have it where there's 2 ways to solve this problem. I'll do it this way without factoring and one without by factoring. Now, the reason I'm saying solve by factoring, you don't have to factor because if you have the square root method, here's the nice thing. I can add 64 to both sides. And if I add 64 to both sides, what that's going to give me is x squared is equal to 64. Well, how do I get rid of that squared? Well, I'm just going to square root both sides. And if I square root both sides, it's going to be a positive and negative value. So then x is going to equal the positive and negative 8, which is true. Now, that was through the square root method. Hey, see that someone's watching now, so just let me know that you're here. One way that we could have done by factoring is by the difference of perfect squares, meaning that you take the square root of whatever this value is and take the positive and negative of it to solve. So then you get x plus 8 is equal to 0 and x minus 8 is equal to 0, which x would be equal to negative 8 and positive 8. Now, here's the thing. Both of these methods are fine. You can do it by factoring, or you can do it by adding that 64 and then square rooting both sides. Either way is fine because we're solving. We're just looking for x. Sometimes factoring will be easier. Sometimes it won't be easier. So case in point, if I'm looking at 9, I think factoring is going to be easier. So let's look at factoring. Now, the way that the square root method works, or it's really not square, the difference of perfect squares. So the difference of perfect square method works is it has to be subtraction. And if it's subtraction, you're going to square root both of these. If I square root 9x squared, that's going to give me 3x. If I square root the 4, that's going to give me a 2. Now, with the difference of perfect square method, we know that a positive and negative goes in between these. And so what we're just going to do is just set both of these equal to 0. So then that's going to be 3x plus 2 is equal to 0. And 3x minus 2 is equal to 0. Now, how do I solve for x? Easy. Get x by itself. So if I'm going to get the x by itself on the left side equal to 0, I'm going to subtract 2 on both sides. And after I subtract 2, I'll divide by 3 to get x is equal to -3. I'll do just kind of the opposite on the right side, where I will actually add 2 first, and then divide by 3, where I'll get the positive and negative 2/3 as my answer. And so I think the hardest part is this factoring, because I think y'all know how to solve one-step equations. Those are fine. So we'll keep going on. Let's start here at number 10. Looking at 10, here's the thing when you're solving. You always want to see if something's in common. Can you factor something out? So if I'm looking at 3x squared plus 21x, is there something in common with both terms? If you take a second and look, you'll see yes, there is. You can notice that 3 goes into 21, so I can essentially factor out a 3. If I factor out a 3, I'm left with a 1 and a 20 and a 7. What also factors out is an x. So then I'm going to be left with 1x here plus 7. Now here's why this is so neat. The reason this is so neat is because then all I have to do is set 3x equal to 0 and x plus 7 equal to 0. Because if 3x is equal to 0, then it doesn't matter what x plus 7 is, because anything times 0 is 0. So this is going to give me 3x equal to 0, x plus 7 is equal to 0. So then when I divide both sides by 3, that will give me x is equal to 0. And if I subtract 7 on both sides, then x will be equal to -7. And bada bing, bada boom, bada done. So let's keep going. Now, we get into the little bit more complicated ones. Now, here's the thing. To solve by factoring, if you're going to truly factor, if you look at the 3 problems that we did before, notice what were they all equal to? They were all equal to 0. Is this one equal to 0? No, it's not. Cameron Page, glad you're with us. Thank you for being here. If you have any questions, let me know. So shout out to Cameron. 11, x squared minus 2x is equal to 35. What I want to do is get rid of that 35, move it somewhere else. So we're going to move this 35 to the other side by subtraction. So that's going to give us then x squared minus 2x minus 35 equal to 0. So this is set up for us where now we can solve it. If I'm trying to solve it, I need to think, okay, what multiplies to 35 that adds to -2? So I'm going to look at 35, or really -35. 1 times 35 works. 2 doesn't go into 35. 3 doesn't go into 35. 4 doesn't go into 35. 5 does. 5 and 7 goes into 35. But notice I need to add to -2. So 5 times 7 does give this. There's a difference of 2. How do I get that negative? Well, if I do 5 minus 7, that would give me the -2. So then that would tell me that my factors are x plus 5 times x minus 7. So then all that it is now is just one-step equation where you do x plus 5 is equal to 0 and x minus 7 is equal to 0. So I can subtract 5 on both sides to get x is equal to -5 and add 7 on both sides to get x is equal to 7. And then we are done. with that one. Let's keep tracking. Taking a look at 12. What we're going to do is, again, notice, can you factor out anything? Can't factor out anything. It's kind of hard to factor something unless if when there's a value here. So what we're going to do is the divide and slide method. And so what divide and slide is, step one is multiply A and C. So you're going to do 4 times 6 to get x squared minus 5x minus 24 is equal to 0. The second thing that you're going to do for multiply or for divide and slide is factor. So that means I'm going to look at negative 24, look at the factors of negative 24, which are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and 1, 64 is just kind of backwards like that. Well, I see I need to add to negative 5 that multiplies to negative 24. Well, I think 3 and 8 will work. If 8 was negative, that would give me a negative 5. So that means when I factor, I'll get x plus 3 times x minus 8 equals 0. Now, are we done? No. Remember, this is a different method, divide and slide. So what we now need to do is divide and simplify. Simplify. So what we're going to do is divide both terms by the value that we multiplied in the beginning. So then this will give us an x plus 3/4 times, let's see, 8 over 4 will simplify us to 2. And now we need to slide. So that means after their fractions are reduced, we'll slide the denominator to the front if there was ever a fraction. And so then that would give us 4x plus 3 times x minus 2. Now, this is if we were factoring. I want to let you notice something. For doing the divide and slide method, I could have stopped right here and done x plus 3/4 is equal to 0 and x minus 2 is equal to 0. If I do that, x is equal to 2 and then x is equal to negative 3/4. So that's like a quick route for us to do that. You can slide it and then solve it, because then you'd have 4x plus 3 equal to 0. So then 4x would be equal to negative 3. And x would equal to negative 3 over 4. It's just, this is an easier one step rather than like sliding it. You could just solve it from there. So that's just one thing to help for divide if we're solving. Factoring is a different story, but for all we're doing is solving, that's fine to do. So let's take a look at another one here. If I'm looking at another one, 13, 12x squared plus 4x is equal to 5. Thing is, I want to get that little equation there equal to 0, because we can't solve it unless the equation is equal to 0. So how do we get it equal to 0? We move that 5 over by subtracting. So then that's going to give us 12x squared plus 4x minus 5 is equal to 0. Now, how can I factor this? Can't really factor anything out. So what we're going to do is divide and slide. And so divide and slide again is we're multiplying the first times the last. And that'll give us x squared plus 4x minus 60 is equal to 0. Let's look at the factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 doesn't go in, 8 doesn't go in, 9 doesn't go in, but 10 does. So now that we've essentially found all of the factors, can any of these add up to 4? Well, these can, and they can if we make negative, if we make 6 negative, so then that would give us 4. So then that would factor to x minus 6 times x plus 10. After we've done that, we're going to divide, and we'll divide the 12 because we multiplied in the beginning. Now we're dividing. Simplify, so then that's going to be x will simplify to 1/2, and x would simplify to 5/6. Now here's the thing. I'm not going to do the slide method. I'm going to actually just solve the puzzle. So if I'm going to solve the puzzle, that'll give me x minus 1/2 to get x is 1/2, and x plus 5/6 equals 0. That'll just give me x is equal to negative 5/6. And that's how you solve by factoring. Now let's take a look at how we can solve by using the square root method. I kind of showed you how we could do the square root method back here. So I did, this was the square root method, and this was by factoring. So just showed you both of those. And so what we're going to do is just how to solve by factoring with, just different values, some with fractions, some with not. So if I'm looking at 14 here, if I'm solving by square root method, I'm square rooting both sides here. When I square root both sides, that'll give me x is equal to the square root of 9 over the square root of 4, because essentially what you're doing is you are square rooting the numerator and the denominator. And so when you square root the numerator and the denominator, that's going to leave you, remember, when we square root two answers, that'll leave you with a 3 over 2, a positive and negative 3 over 2. And that's just through the square root method. That's the simple version. Of course, things are a little bit more complicated than that. So like if I was looking at 15 here, the goal for the square root method, you got to get the x squared by itself. You got to isolate the x squared. So how do we get the x squared by itself? We add 7 to both sides. So we'll get x squared is equals 7. How do I get rid of that square root? Square root that guy. So when I square root that guy, that'll give me x is equal to the positive and negative square root 7. Keep in mind, remember when we square root, we're getting a positive and a negative number every time, all day, every day. Let's see how we work in. All right, let's keep going. Taking a look at 16. Now I got x squared plus 9. If I'm looking at x squared plus 9, I got to still isolate that x squared. So if we're going to isolate the x squared, I got to get rid of that 9. So I'm going to get rid of it by subtracting. So then x squared is going to be equal to negative 9. Square root that guy. If I square root that guy, that'll give me positive and negative square root of 9, or of negative 9. Here's the thing. Is anything, is this our final answer? Of course it's not. Why? Because the negative number. So if there's ever a negative underneath the radical, we got to make sure we factor that guy out. So pretend that the i's there. But what do you notice about this 9? What's the square root of 9? Ooh, I know. It is 3. So really, our final answer is going to be positive and negative 3i. Now, you could just go from step 2 to the 4 right here. This is just more of a step-by-step process. Some people work that way, others don't. So here's the trickiest one that you'll see for the square root method. Notice we have a binomial squared equal to a fraction. Since this binomial is squared, rather than explode it out and solve it, that's just too complicated. What we can do is square root both sides, because if I square root both sides, that essentially just gets rid of that binomial. So then I'm just left with the x plus 4 or x plus 7. And then, of course, that's going to be equal to the square root of 49 over the square root of 16. So x plus 7 is going to be equal to 7/4. But remember, it is a positive and a negative value. So we'll just subtract 7 on both sides. So then x would be equal to 7/4 plus 7. And x would be equal to 7/4 minus 7. Now, when we add values, we got to find a common denominator. And the common denominator here is 4. So I'm going to multiply 7 by essentially the value of 1, which is 4 over 4. So then that would give me 28 over 4. Now, that then will give me 7/4. Ooh, sorry. Timeout. This should be sorry, right here. This should be x is equal to positive negative 7/4 minus 7. So I need to, this is where I messed up. This should be positive here. I'm going to leave that positive. This should be negative. So I didn't really mess up. Just as a little mishap. And so this should be a minus. So then now we have 7 over 24 minus 28 over 24. So then that would give me negative 21/4. And again, that's I just skipped a step. So just to recap, this was the positive negative 7/4 minus 7. So you're taking 7/4 minus 7, and then now we're looking at negative 7/4 minus 7. So we know that this is 7/4, or it's negative 7/4. And then we're subtracting that 28 over 4 to get equal to negative 35 over 4. So then x equals negative 35 over 4 and negative 21 over 4. Looking here at 18, we're going to solve by graphing by using a calculator. Now I'm going to show you, this is the recap for the calculator. The first thing that you got to do, step 1, is get the equation equal to 0. So how do we do that? Subtract 4x on both sides and 8. The reason I do that, I just like having a positive x squared, or yeah, that's the whole reason. I just like having a positive x squared. So I'm going to plug this guy in the calculator. If I'm going to plug it into the calculator, what we're going to do is open up the calculator, go to your y equals, and then we're going to hit plug it in. So that's going to be x squared minus 4x minus 8. So I've plugged in the equation here, and now I'm going to graph it. The reason I'm going to graph it is because it should give you a parabola. So what we're going to do is find the value of your x-intercepts, also known as the roots or the solutions. The way that we find these values is by using this kind of second trace button here. So what I'm going to do is hit the button second, then trace. I'm going to find the 0. Now the calculator is going to ask about this left bound. On the left bound, what I'm going to do, it's just asking you need to be on the left of the 0. So if my 0 is located here, I need to be on the left side of it without there being any other zeros included. So I'll hit the enter on the left bound. Notice that an arrow comes up. It says, hey, you're looking at everything this way. For the right bound, I need to be on the right of this 0, but not all the way to here, just like right here. And I'll hit enter again. Notice that essentially I'm trapping this 0 in between my 2 arrows. It's going to ask for a guess, but the guess, I don't really know why. So you just hit enter one more time. And so then our 0 will be negative 1.46. Now, how do we find the other 0? Same process. We're going to do second trace, find the 0, but I'm going to go to the left side of my 0. Now, the left doesn't mean above. It means if my 0 is here, I'm on the left to it in terms of x. So I'm going to hit enter on my left bound, going up to the right side of that 0, hit enter on there again. So that essentially traps the 0. And so then I'll find that my 0 is 5.42. Now, if the y gives you another value besides the 0, it's like 2 times e to the negative 12. Like, don't worry about that. It's supposed to be 0. It's just very, very close to 0. So that would tell us then that for 18, our answer would be negative 1.46 and 5.46. So again, we got it equal to 0. Then we wrote graph and the y equals. After we wrote the graph and the y equals, we hit graph just to see it, and then we went to second trace, and then we hit the 0, and then we had the left bound, right bound, and that's how we found the zeros. So let's just do another one. Like if I'm looking at 19 here, it's already set as equal to 0, so that's kind of nice for me. So all I'm going to do is go to that y equals. I can clear the equation just by hitting the clear. And I'm going to do 2x squared minus 2x minus 5. Graph it just to make sure I graph the right thing. I could guess, but I don't want you to guess. I want you to be exact. And to be exact, we're going to go second trace, go to that 0 button. On the left bound, I need to be on the left side of my 0. On the right bound, I need to be on the right side of my 0. And so this would give me negative 1.16. So if I'm going to find the other 0, I'm going to go down to that 0. And then I'm going to be on the left bound of my 0 and go to the right side here. So it's all relative to this location here, not this 0 axis, but this location. And then that'll give me 2.15. So then that would tell me for 19, negative 1.16 and 2.16 would be my two zeros. That's what x would be equal to. And so here we had our x is equal to negative 1.4 and 5.46. Now, we've looked at solve by factoring, solve by square root method, solve by graphing. Now there's two more that I want to look at: completing the square and the quadratic formula. And so with the completing the square and the quadratic formula, what we're going to do for completing the square is the first off, you need to get excuse me. For completing the square, you want to get all x's on one side. So how can I get all x's on one side? Subtract 2x on both sides. So that'll give me x squared minus 2x is equal to negative 5. I'm leaving a blank here because completing the square, if you remind ourselves, our goal is to essentially create a perfect square trinomial. So the way we create a perfect square trinomial is by taking our b value, dividing it by 2, so then that's negative 2 over 2, and squaring it to get a negative 1 squared, which is a 1. What that does then is we'll add 1 to both sides. So we find, this is again, we find our half value and square it. The reason that we have our half value is the half value is essentially the insertion of our perfect square. And then from there, we just set it equal to whatever was on the right side. So that's going to be equal to negative 4. And solve. So to solve, you just square root both sides to get x minus 1 is equal to the square root of negative 4. Now, the square root of negative 4 is too high. And so because it is the square root, it's the positive and the negative version of it. What we're going to do is add 1 to both sides. And remember that I like it in standard form. So let's put the real number first, followed by the imaginary number. And so with this completing the square, it's finding your half value. Then after you find your half value, that should create that binomial that's squared, and then set it equal to whatever was left over. So let's look at another one. The question is, are these x's by themselves? No, they're not. So I'm going to add 12 to both sides. So then that would give me x squared minus 4x is equal to 12. And again, leaving a blank for us there so that I can complete this square. So I'm going to take this negative 4, divide it by 2, and square it, which would give me a negative 2 squared, which is a 4. What we do with that 4 is we add it to both sides. Now, on the left side, this creates a perfect squared trinomial, which means this would factor to x minus whatever the half value was squared, which would equal 16. This one's going to work out nice for us. And so the way it's going to work out nice is we're going to square root both sides. So get x minus 2 is equal to the positive and negative. Well, square root of 16 is 4. So what I'm going to do is add 2 to both sides. And if I add 2, I'll get 2 plus or minus 4. Now, this is not simplified. We got to simplify it. So I'm going to look at x is equal to 2 plus 4, which is 6. And then x is equal to 2 minus 4, which is negative 2. This is my final answer. Is 6 and negative 2. Now, you could do this by simply factoring, but not in the case. So looking now at this last one for completing the square. For completing the square, I got 2x squared is equal to negative 8x plus 45. What's the goal first? Get the x's by itself. So for completing the square, we always got to get these x's by themselves. So then that's going to give us 2x squared plus 8x is equal to 45. And so, oops, I didn't leave a space, but that's okay. Because here's the thing, you cannot complete the square if there's a value in front of x squared. So what we got to do is factor out this 2. Not factor out, sorry, divide out the 2. So I'm going to divide out the 2, which would give me x squared plus 4x is equal to 45 over 2. Now, don't be worried about this fraction. Leave it as is. We'll get to it in a second. And so I have essentially my blank for completing the square. I'm taking the 4, dividing it by 2, and squaring it, which is really 2 squared, which is 4. So I'm going to be adding 4 to both sides. Now, I mean, the left side is not terrible because that's just going to give us x plus 2 squared. Now, to add 45 over 2 and 4, we got to find a common denominator. And that denominator is 2. So I'm essentially going to multiply by 2 over 2 to get 8 over 2. When we add these, that gives me essentially 53 over 2. Now, when I have 53 over 2, what we're going to do is essentially get rid of this squared. So we're going to square root both sides to get x plus 2 is equal to the square root of 53 over 2. Now, keep in mind, this is the positive and negative value. But one thing is I can't have, and then with this, what I'm going to do next is subtract the 2 on both sides. So then x would be equal to negative 2 plus or minus the square root 53 over 2. So far, so good, so bueno. Good, good, good. Let's keep going. So that's essentially completing the square. If you have questions about completing the square, please let me know. Now the last style of solving is going to be through the quadratic formula. So, of course, the quadratic formula, same thing with completing the square, same thing with factoring, same thing with all solving. You have to have it where it's equal to 0. So the question is this equal to 0? It's not. So we're going to subtract then the 3x and the 2 and move it to the other side. So then that's going to be x squared minus 3x minus 2. The reason I'm doing this, it's not always moving right to left. I just like it where I have a positive x squared. Now we're going to have to know these formulas. So let's sing the song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula. Our a value, and that's kind of based off of the standard form of ax squared plus bx plus c. So our a value is this 1x. The b value is negative 3. The c value is negative 2. So basically, it's just a plug and chug. So that's going to give you negative of a negative 3 plus or minus the square root of b squared minus 4ac all over 2a. So this will be 3 plus or minus the square root of 9 minus 8 over 2, which is 3 plus or minus 1 over 2. Now, this is not done. Once you're set here with the whole number, what we need to do is, oh, timeout, pause. See an error, see an error. Give you a second. Where did I mess up? This negative 2. I messed it up. That should have been a negative here. So, because that should have been a negative right there, this would have been 3 plus or minus the square root of 9 plus 8 over 2. Well, then that's just going to be 3 plus or minus the square root of 17 over 2. And that will be our final answer. Now, sometimes we're going to have to simplify these guys. So if the square root or if the number underneath the radical simplifies, simplify it for me. Let's look at 2 more for quadratic, and then I think we're running out of time. So I'll look at one of those, solve each equation by any method. Again, that's just factoring, and then we'll look at maybe 3 or 4 flashbacks. Actually, I think I'm just going to do the quadratic equation one more time, because essentially it's the same thing, where you're just plugging in the values of x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's just because I got to get home. So sorry that I'm cutting it a little short. So again, we're identifying by getting everything on one side. I like to have it where, oh, you know what? Let's do 25. Let's do 25 because this. The reason I want to do 25 is because it's just a little bit more math, and it deals with me moving the x squared now. So here's the thing: you want to set it equal to 0. So I don't like having a x squared that is negative. So because of that, I'm going to add the 2x squared and subtract the 3x. So then I'll have 0 equal to 2x squared minus 3x plus 24. You will get the exact same answer if you did it the other way. I just like it where a is not negative. That's just a preference for me. When you're here, see, does anything divide out? Because I'll make the math a little bit easier. In this case, it does not. So my a value is 2, my b value is negative 3, my c value is 24. So now it will be a negative of a negative 3 plus or minus the square root of b squared minus 4ac all over 2a. So then that will give me 3 plus or minus the square root of 9 minus, let's see, 4 times 2 is 8. 8 times 24 is 192. And then 2 times negative 2 will be a negative 4. This simplifies to 3 plus or minus the square root of, I think that will be negative 183 over negative 4. And here's the neat thing. The square root of negative 183 does not simplify except for the negative value. Remember, if you ever have a negative in there, you got to find that value. And so that was essentially solving through the quadratic formula. One thing I want to do for factoring, just to recap, if you're looking at 26 to 28 here, any method, all the methods, the 5 methods that we talked about, you can do. You're going to be asked to do completing the square. You're going to be asked to do the quadratic form. You're going to be asked to do the factoring. You're going to be asked to do the by graphing. But one thing I want to look at is number 30, because sometimes you can make it simpler than it already is. And so with that being said, what I want to do is solve this. So if we're trying to solve this, we got to first off get it equal to 0. So I'm going to add 4 to both sides to get 2x squared plus 6x plus 4 is equal to 0. Now, to factor this, your first thought might be, oh, let's do the divide and slide. Well, I don't want to do the divide and slide. I'm just going to divide out the 2. Because what's in common with each term? That 2. So that means I'm going to divide each term by 2. If I divide everything by 2, because 2 goes into all of those numbers, that then's going to leave me with an x squared plus 3x plus 2 is equal to 0. Now, I could have done this step here. I could have done and divided everything by 2 and gotten the same thing. I could have done that. It's just doesn't really matter. It's just another way to do it. From here, I'm just going to do the factor method. So what multiplies the 2 that adds to 3? Well, that's going to be 2 and 1. And so then that'll just give me where x is going to be equal to -2. And then x is going to also equal -1. So that's just a little thing about factoring. I want to spend the last 5 or so minutes looking at some flashbacks. And so looking at some flashbacks, let's take a look at, let's see, we'll see. We'll see how much time. So let's look at absolute values, because I've noticed on a lot of tests there's been a lot of issues with absolute value. So with absolute value for solving these, what we want to do is get the absolute value. So this thing right here, we want to get this by itself. Now the way we get it by itself is divide out this 2, get rid of that guy. So then that's going to be x plus 2, it's going to be less than 2. Now if it was something like this, first add the 1, then divide the 2. So that's just to help you out for future. This isn't the problem that we're doing. So this is not part of the problem. It's just a matter of like, hey, you should probably practice that. Once you get to here, you're essentially solving this in 2 ways. One, where x plus 2 is less than 2. And then another is with a -2. Now remember, what happens when we change the value? You flip the sign. So to solve this, we'll subtract 2 on both sides to get x will be less than 0. Subtract 2 on both sides, where we'll get x is greater than -4. So because x is less than 0 and x is greater than -4, in interval notation, this would be written as from -4 to 0. Because interval notation is the lowest value to the highest value. One thing to look at this if you're going to graph it. If you had 0 here, -4, you know x is going to be greater than. So that would be greater than. And then 0 is less than. So it's just in between those two values. And that's how you solve for absolute. Now, if I'm looking at something like 34, 34 is essentially, if we're trying to determine f of 5, these things are easy. What f of 5 is, you're going to go to the 5 is essentially here. Remember that this is function notation. This is your x value. So it's just whatever x value you get, what is your y? So if I'm looking for the function of f of 5, I'm going up to on my graph. Whatever this y value is will be my answer. So in this case, that will be 1. So f of 5 should be 1. So that's essentially how you would do 34, is find out where x is and then see where it is on the graph. For 35, we've done 35. That's essentially factoring. let's take a look at, we'll look at 36 and 37, and then I'll ask if there's any other questions for anyone else who's watching, and we'll be done from there. So for 36 here, this is a doozy. Whenever we're simplifying, you want to go from the inside out. So first off, does this x minus 1 simplify? Does not. So because it does not, we're going to leave it as there. So let's simplify. Does 6 times x minus 1 plus 2 simplify? It does. That'll give us 6x minus 6. I got that through distributing plus 2. Right now, I'm just working on this left one. And so then that will essentially simplify to 6x minus 6x plus will be 6x minus 4. Now, we did the left side. Let's do the outside. Does 3x minus 1 simplify? Does not. So what about the 2x times 3x minus 1 plus 2? That will. So we'll distribute the 2 to get 6x minus 2. And then add this 2. And then this should give us 6x. Let's see, this minus 2 plus 2 should be 0. So then it'll be 6x just by itself. Now what we're going to do is simplify the inside here. So then this will be 3 times 6x minus 4. This is essentially distributing that negative 1. So that'll be a negative 6x. When we simplify this, 6x minus 6x will just be 0. So then this will be 3 times negative 4. Now this is, again, this bracket is essentially a parentheses. And so in that case, 3 times negative 4 will give us a negative 12. And the last one is going to be 37. And this is evaluate. If it says evaluate and you're given these values of x is equal to 3, y is equal to 5, wherever there's an x, plug in a 3. Wherever there's a 5, plug in for y. So I see an x here, so that's going to be essentially a 3, a 5, and a 3. So that's what you're doing, essentially, is just plugging those in. So that's going to be 3 plus y, which is 5, times 4 plus 3 squared. And you're going to simplify kind of how you did before, inside out. So that 3 plus 5, we're not adding those. We need to simplify this 3 squared first, essentially using the idea of PEMDAS. And so this will be 4 plus 3 squared, which is 9. Now, can we simplify the inside? We can. So 9 plus 4 will give us 13. And then 5 times 13 would give us 65. And then 3 plus 65 will give us 68. So there we go. That'll give us the 68 here. Now, that's 8 o'clock. I see that there's 2 people streaming. So the question is, do you have any questions? I know Cameron's one of them. Are there any questions before I hang up the hat? Cameron's one of them. Are there any questions? Cameron's one of them. All right. I don't see any questions. And so, again, if you have any, just check out tomorrow. And so hope to see y'all. Well, not tomorrow. I'll see y'all either tomorrow morning or tomorrow afternoon. Or let's see. Where is this? So, yeah, I'll see y'all. I'm going to stop screen sharing. Okay. So, yeah, see y'all tomorrow. Or see you Thursday, just letting you know. And thanks for checking in. I'm going to post this on the topic page. Have a good night.